for individuals seeking hands-on training in local area network installations, specifically concerning CAT5E, Cat6, and unshielded twisted pair terminations. Several recommended courses and resources are available. These cater to varying levels of expertise, from basic installations to advanced design and troubleshooting. One prominent organization is BICSI, which offers the Certified Installers Program, designated as IST. This basic course comprehensively covers local area network installations encompassing cabling, terminations, and troubleshooting techniques. For those looking to advance their knowledge, BICSI also provides the Certified Telecommunications Distribution Designers Program, identified as CTDD. This intermediate course delves into local area and network design and implementation strategies. An alternative route is through CompTIA, which offers the Network Plus Technician certification. This program includes a module focused on network cabling and terminations, offering a broader information technology perspective alongside the specific cabling skills. Several other institutions provide specialized local area network cabling training. Leviton, for instance, operates a local area network cabling school that emphasizes hands-on training in local area network cabling and termination procedures. Fluke Networks offers Fiber University, which provides courses concentrating on fiber optic cabling and termination, expanding skill sets beyond copper cabling. Netcomm Training delivers courses encompassing local area network cabling, termination techniques, and network design principles. CABEX Training furnishes hands-on training in both copper and fiber cabling installations, offering a versatile skill set. The National Electrical Contractors Association and the International Brotherhood of Electrical Workers jointly administer an apprenticeship and training committee known as NECA/IBEW. This national apprenticeship program incorporates training in local area network installations, offering a structured career path. When selecting a class, several factors should be considered. Firstly, prioritize hands-on classes that provide practical experience. Secondly, assess the current knowledge level and choose a course that aligns with individual needs. Thirdly, check for industry-recognized certifications that the course offers. Fourthly, consider reviews and testimonials from past participants. Fifthly, inquire about the instructor's experience and credentials. The availability of these classes spans across various locations nationally. It is advisable to consult with the specific providers to obtain information on their current schedules and locations. When working with network cabling, it is critical to adhere to industry standards and best practices to ensure reliable and high-performance network infrastructure. Several key aspects must be considered. Firstly, cable selection. Choose the appropriate category of cable, such as CAT5E, Cat6, or CAT6A, based on the network's bandwidth requirements and the distance limitations specified by the standards. CAT5E cables are suitable for gigabit Ethernet applications over shorter distances, while CAT6 and CAT6A cables support higher bandwidths, such as 10 gigabit Ethernet, and offer improved performance characteristics. Secondly, cable handling. Avoid kinking or bending cables excessively, as this can damage the internal conductors and impair signal transmission. Use proper cable management techniques, such as cable trays and tie wraps, to maintain cable organization and prevent strain on the connections. Thirdly, termination practices. Follow the TIA/EIA 568 or 568 rewiring schemes consistently when terminating cables into connectors and patch panels. Use a high-quality crimping tool to ensure secure and reliable connections. Inspect the terminated ends to verify that all wires are properly seated and that there are no exposed conductors. Fourthly, testing and certification. After completing the cable installation, use a cable tester to verify the continuity, wire map, and performance characteristics of each cable run. Certify the cables to ensure that they meet the requirements of the relevant standards, such as TIA/EIA 568. C. When dealing with unshielded twisted pair cabling, several factors can affect signal integrity and network performance. Firstly, electromagnetic interference. Unshielded twisted pair cables are susceptible to electromagnetic interference from external sources, such as power lines, fluorescent lights, and radio transmitters. To minimize interference, keep cables away from these sources and use shielded cables in environments with high levels of electromagnetic interference. Secondly, crosstalk. Crosstalk occurs when signals from one twisted pair interfere with signals on adjacent pairs. To minimize crosstalk, use high-quality cables with tight twisting and proper shielding. Maintain proper separation between cables and avoid running them parallel to each other for long distances. Thirdly, impedance mismatch. Impedance mismatch can cause signal reflections and reduce signal strength. To minimize impedance mismatch, use cables and connectors with matching impedance characteristics, typically 100 ohms for data networks. Fourthly, cable length. The maximum cable length for unshielded twisted pair cables is specified by the TIA/EIA 568 standards. Exceeding these limits can result in signal degradation and reduce network performance. Use repeaters or switches to extend the network over longer distances. When working with different categories of cables, it's important to understand their respective capabilities and limitations. CAT5 cables are commonly used for gigabit Ethernet applications and can support data rates up to 1 gigabit per second over distances up to 100 meters. CAT6 cables offer improved performance characteristics compared to CAT5E and can support data rates up to 10 gigabits per second over distances up to 55 meters. CAT6 cables provide even better performance and can support 10 gigabit Ethernet over distances up to 100 meters. Fiber optic cables offer several advantages over copper cables, including higher bandwidth, longer distances, and immunity to electromagnetic interference. Single-mode fiber is used for long-distance applications and can support data rates up to 100 gigabits per second over distances up to 40 kilometers or more. Multimode fiber is used for shorter distance applications and can support data rates up to 100 gigabits per second over distances up to 550 meters. When terminating fiber optic cables, it's essential to use proper tools and techniques to ensure low insertion loss and high return loss. Use a fiber cleaver to create a clean and precise cut on the fiber end. Use a polishing machine to polish the fiber end to a smooth and flat surface. Inspect the fiber end with a microscope to verify that there are no defects or contamination. Testing and troubleshooting are critical aspects of local area network installation and maintenance. Use a cable tester to verify the continuity, wire map, and performance characteristics of each cable run. Use a network analyzer to identify and diagnose network problems such as packet loss, latency, and errors. Use a time domain reflectometer to locate cable faults such as shorts, opens, and impedance mismatches. Use a light source and power meter to measure the optical power of fiber optic cables. Safety is paramount when working with network cabling. Always wear safety glasses to protect your eyes from flying debris. Use caution when working with sharp tools, such as cable cutters and strippers. Avoid working in wet or damp conditions to prevent electrical shock. Follow all applicable safety regulations and guidelines. In addition to the technical aspects of local area network installation, it's also important to consider the business and project management aspects. Develop a detailed project plan that outlines the scope, schedule, and budget for the installation. Obtain the necessary permits and approvals from local authorities. Coordinate with other trades such as electricians and contractors to ensure that the installation is completed smoothly. Communicate effectively with clients and stakeholders to keep them informed of the progress of the installation. Provide training and documentation to end users on how to use and maintain the network. When troubleshooting network problems, it's important to follow a systematic approach. Firstly, define the problem. Gather information about the symptoms such as error messages, slow performance, or intermittent connectivity. Secondly, isolate the problem. Determine which devices or cables are affected by the problem. Thirdly, identify the cause. Use diagnostic tools and techniques to identify the root cause of the problem. Fourthly, implement a solution. Apply the appropriate fix to resolve the problem. Fifthly, test the solution. Verify that the solution has resolved the problem and that the network is functioning properly. Documentation is essential for maintaining a well-organized and efficient network. Create detailed diagrams that show the physical layout of the network, including the location of cables, connectors, and devices. Maintain records of all cable tests, certifications, and repairs. Keep track of network configuration settings, such as IP addresses, subnet masks, and DNS servers. Regularly update the documentation to reflect any changes to the network. In summary, local area network installation involves a comprehensive understanding of cabling standards, termination techniques, testing procedures, and troubleshooting methods. By following best practices and adhering to industry standards, individuals can ensure the reliable and high-performance operation of network infrastructure. Continuous learning and professional development are essential for staying current with the latest technologies and techniques in the field of local area network installation.